Yo, welcome. Today we are gonna talk about this interesting do-it-yourself simple LED universal driver. You could call it like that. Yeah, the reason is, you can see from the title, is because I found this in the recycling place and it's a pretty fun lamp, not gonna lie. But I don't want to make it mains powered because on my desk I don't really have that many plugs available and it would be cool to make this portable. So I've decided to compile the parts which are here. We're gonna have a 3S 18650 battery pack. This is very standard. I have the BMS here. Here are all my components for this. Here's the LED. This is a Chinesium Cree 10 watt LED, but it's gonna do the job fine. And I already actually have built this before because I have this headlamp that I always use and the driver is in here. This is this circuit right here, but in this case I'm gonna build this one. The reason is I don't have a 1K potentiometer at hand right now, so I'm gonna use this version, which should be pretty much the same. It's just a bit different, and I'm probably gonna adapt some of the components from this to here, like this 10 ohm resistor. I like to have the MOSFET gate switched over a small resistance with the NE555. Don't like to have it directly. But yeah, as you can see, this is not by my design, though it is a very clever design and I like all the circuit that this person publishes. This is from Scotty. He's Hungarian. Here you can see the website. Yeah, I've credited him because he says on his website that you should credit it, and I'm probably gonna put the website and the link to the page to these circuits in the description. And yeah, I gotta say, on his website there are a ton of very interesting circuits, like I think the Tesla coil from the Udon gun, like the circuit, the pre-design was also made by Scotty, and a lot of like Chinese Tesla coil copies have used that circuit now. But yeah, enough trivia. I guess let's get into this. I can give like a basic explanation how this works. This is basically a step-down converter, but it's not like a regular step-down converter because it uses the MOSFET in the negative side. And we do this because driving a high side MOSFET is somewhat complicated. So instead we do it on the lower side, and we don't need a separate voltage or optocoupler or something like that. And yeah, this makes it way easier. You just invert it, it doesn't really matter. You have your inductor, standard stuff. This is the current setting resistor. I will have to experiment because this circuit is originally designed for 1 amp and I don't remember which resistor I used in my headlamp. So I have a bunch of resistors here which we can try. I'm too lazy to calculate the value. I have some 0.27 and 0.33 ohm resistors and some other types as well. Yeah, this basically works with a PWM generator, and the PWM gets adjusted by this transistor depending on the voltage drop of this resistor. Basically it takes this, subtracts the voltage drop from the transistor, and then it does some regulation here over this diode. It like compares the voltage and then it pulls this high and then gives more duty cycle, and low and then it does less. Basically like that. And yeah, basic PWM stuff. You don't really question this. I mean, I haven't designed the circuit either, so I don't really know what's going on. I just know it works, and that's all that matters. Alright, I guess I'm gonna start building them. Oh, I have these fun vintage capacitors that I found from one of the circuit boards from the big haul that I found this scrapyard. You can see it in my community posts. These are fun. These are 100 nano at 16 volts apparently. It's a very low voltage for ceramic capacitors. But yeah, other than that, there is not much interesting going to happen here. I guess the mechanical build is also gonna be relatively simple. I'm gonna use these two holes here to like make a bracket, then screw it onto this. And yeah, this actually is clipped on here, and this can be unscrewed here, and then this is gonna get and then and yeah, you get the idea. This opens back here, and here you have the real estate. I already secured this switch with some hot glue because it was moving around. It works. Yeah, the battery fits in here pretty perfectly, like this. Here's gonna be this PCB, gonna be right here, and probably the pot somewhere here or here. Yeah, that's how it's gonna fit. And if I was any other YouTuber, this would probably get like 500,000 views because, you know, wow, recycling, wow. But because I'm genuine, it's probably only gonna get like 20 or 50. But we don't care. We are here for the fun of it. I actually need this lamp for myself, so I would have just built it without making a video, but it's a fun opportunity, so let's do it. The abomination has been finished. I mean, it works, so does it even matter? There we go. The lower regulation area is a bit wonky, but I suppose that's the NE555 that doesn't know how much duty cycle to do. I mean, could also be the pot and terminal. It's not at full power, it's about 60% of the LED power. Oh, I can hear it. That's fun. Should maybe run this and see if the MOSFET doesn't get too hot. And if it would have gotten too hot, it would have already gotten too hot. So it works fine. The current sensing resistor is surprisingly small. It's two 0.1 ohm resistors in parallel, so it's 50 milliohms. That's quite little for like a a transistor a single transistor current sensing circuitry, but this is like cheated because it uses the two Schottky diodes as biasing, so it already starts where the transistor is already like barely conducting. That's why it can sense currents that low. I mean voltages, like the voltage drop across the resistor, but yeah, it works. I guess the only thing left is make the bracket, make the thing, make the battery pack, put everything in with hot glue and call it a day. This is probably gonna work fine. This resistor I can like bend around. I put it like on longer wires. You can see the build here. There's the MOSFET. Hold on, let me get my pointer. Here's the MOSFET. There is the diode. The NE555, the capacitor. The 47K resistor goes across here. There's the 6.8, the 2K resistor, the two Schottky small signal diodes, the two 100 nanofarads, the output capacitor, input capacitor, the transistor, the base wire that goes over here to the 2K resistor and the potentiometer. There's the LED, and yeah, not much else to say. I guess I can like see if it's gonna fit, but hold on, losing focus here. See if it's gonna fit, but I'm sure it's gonna fit. It's not that big, and I don't really need that much real estate. Just have to put in this charger as well, which is also gonna fit nice. It's like really small. This is left over from the udon gun when I still wanted to make it a 3S power source, but then I went to 4S, so the 3S charger kind of was redundant, but now it's gonna be useful because the lamp here is gonna be able to be charged with USB-C, which is kind of nice and practical. Yeah, so I guess this is not really a video about the mechanical build, so yeah, this LED driver works. I would still suggest to build this circuit instead, because this circuit is a bit more stable, like on the low regulation range. I can like connect the battery here and show how this one operates in the lower range. You can see this one doesn't really go completely down to zero. That's why it's a bit more stable. But yeah, this circuit is like temperature and voltage dependent a bit. Sometimes it regulates to zero, sometimes it doesn't. I guess that's a quirk from this circuit only having like one diode as like pre-charge for the transistor. Because this is obviously 0.55 volt if the transistor is also 0.55 volt, like it changes this temperature, the voltage drop of the junction of both like silicon devices, so it sometimes does like things. But yeah, I wanted to try this version because I had the Schottky, the small signal Schottky diodes and the 2K potentiometer, but I think this circuit is still superior than this one, all things considered, at least for higher currents, because if I increase the sensing resistor here, this circuit gets more stable as well, because there's obviously more voltage drop and it's not a few millivolts up and down. That's like very, very sensitive on the low range, so that's the reason why. And yeah, I guess that's it. I'm gonna then finish this build and then show it off in the end, and then the video is gonna be finished. So let me do that. Boom, there it is. I have the thing connected here. You can see the screw, there's like a bracket with like dampening. We have the wire, here's the whole system. Without changing this inductor, because with this inductor here it was going into the audible range, which is not nice. I don't want to have a whining desk lamp. But yeah, we have the 3 cells here, charging board, the BMS, pot switch. Oh, there you go. If I switch it on, you can't really see the brightness control because the camera compensates, but there you go. Also, by changing the inductor, the lower brightness range is now way less finicky. So I guess it just needed less inductance. I did like measure the inductor, but I guess it wasn't low enough. Guess you gotta experiment with this value there. Alright, let's do the final thing and then call it good. Actually, I have a screwdriver over here, which is putting this thing here on. Will it fit? That should be enough. Can always add screw down later. Boom, desk lamp. Is it top heavy? A little bit, but it does work. There we go. Now I have a wonderful portable lamp. Look at that. All right, that is going to that's going to conclude the video. I will see you next time. Actually, before I go, there's gonna be a lot of videos coming up. The next thing is gonna be the inspection and actually getting the television running, the Vanguard. So I guess you're gonna look forward to that. I kind of needed this. I needed this lamp for that. That's why I made this video first. So yeah, now you know. All right, I will see you next time. Later.